Chiral and achiral molecules. Namaskar and welcome to my channel. In this lecture, I am going to teach you what is the chiral molecule, what is the achiral molecule, what is the enantiomer, what is the diastereomers, what is the racemic mixture, what is the meso-form, what is the formula to calculate the isomers. Now, chiral and achiral molecules, when four different groups are attached to a carbon atom, then molecule becomes asymmetric. The carbon atom is called chiral center and molecule is called chiral molecule. Achiral is the reverse of chiral, that is, four different groups are not attached with the carbon atom. In case of lactic acid, the central carbon atom is attached with the four different groups, that is methyl, hydrogen, hydroxyl and carboxyl group. That is the reason lactic acid is the chiral molecule, whereas in case of ethanol, central carbon atom is attached with the two identical hydrogen group, and that is the reason this is not chiral molecule, this is the achiral molecule. Now question come, what will be criteria for chirality if a molecule contains more than or equal to two asymmetric carbon atom? We'll discuss in next slide. Molecule containing two or more than two chiral centers. When a molecule has two or more than two chiral centers, then molecule should not have any plane of symmetry to show chirality. If a molecule has two or more than two chiral centers and have also plane of symmetry, then it becomes achiral. This is also called Meso-form. This is one of the isomer of tartaric acid. Despite having two asymmetric carbon atoms, X, the whole molecule is achiral because it has a plane of symmetry. These are two asymmetric carbon atoms, but it has plane of symmetry. That is the reason this is not a chiral molecule. Iron molecules are like left and right hands. They are mirror images. Right and left hands are non-superimposable on their mirror images. Chiral compounds are optically active. That means they rotate plane polarized light either in left hand direction or right hand direction depending upon their configuration. Here, left hand is the mirror image of right hand and right hand is the mirror image of left hand. They cannot be superimposed and hence left and right hand behaves like a chiral molecules. In this example, the molecule which is on left hand is the mirror image of the molecule which is on right hand. Similarly, the molecule which is on right hand is the mirror image of the molecule on left hand, but they cannot be superimposed, and that is the reason these are the chiral molecules. Enantiomers, Diastereomers, Racemic and Meso-form. Molecules with a chiral center are non-superimposable on their mirror image are called enantiomer. Enantiomers have same physical and chemical properties. D-lactic acid is an enantiomer of L-lactic acid and vice versa. Racemic is 1:1 mixture of each enantiomer. In this example, that is lactic acid, D-lactic acid is mirror image of L-lactic acid. Similarly, L-lactic acid is the mirror image of D-lactic acid, but they cannot be superimposed, and that is the reason D-lactic acid and L-lactic acid are enantiomers. Chiral isomers that are not enantiomers are called diastereomers. It has different chemical and physical properties. Molecule must have two or more than two chiral centers. Meso-form. Despite chiral carbon atom, molecule is achiral. Chirality is lost by internal compensation. I am going to discuss it. First, take example of a structure 1 and 2 of tartaric acid. Structure 1 is the mirror image of structure 2. Similarly, structure 2 is the mirror image of structure 1, but these are not superimposable. Hence, these isomers of tartaric acid are enantiomer. Now coming to structure 1 and 3 and 2 and 3. 1 and 3 and 2 and 3 are not mirror image of each other, and hence these are diastereomers. Coming to Meso-form, in structure 3 there is a plane of symmetry. Upper part is identical with the lower part. Suppose upper part is rotating in the right hand direction, then lower part will rotate in the left hand direction, and hence optical activity will be nullified. Hence, this is not optical active and this is not chiral molecule. This is achiral molecule. Chiral isomers are calculated by formula 2 to the power n, where n is the number of chiral centers. In structure 1, there is only one chiral center. Hence, 2 to the power 1, there will be two isomers. In structure 2, this is nothing but ezetimibe. There are three chiral centers. Hence, 2 to the power 3, that is, it will have 8 isomers. We are going to discuss all 8 isomers in next slide. These are the structure of ezetimibe along with its isomers. Now question comes, how all 8 isomers will be separated? To know the answer of this question, watch my upcoming lecture, Chiral Separation Method Development. Subscribe to my channel and hit the bell icon. For any doubt related to this lecture, write in the comment section and I will answer on priority basis. Thank you.